again a case study from a previous question paper of CBSE. On the left hand side, you can see it is 55/2/1, and you can see the series also mentioned here. The question is pertaining to young double slit experiment. You can see optics is one of the most favorite topics in board examination when it comes to case study. Although I'm not very sure why, but this seems to be favorite, and semiconductors also, by the way. But I will do case studies for all the chapters one by one, and whatever I am able to find from the previous question papers, I am solving them for you. Very useful to revise your concepts and revisit your knowledge of young double slit experiment, and the quality of questions is also very nice. So let's start with this question and read this. So the British physicist Thomas Young explained the interference of light. He observed the interference pattern, and it's a standard, right? So the dark and bright fringes getting made, and I think the key emphasis is the fringe width. And I told you, you have to revise all the formulas pertaining to young double slit. There is a video I have where I have done a consolidation and summary of all the formulas. Please ensure that you go through that formula, and it will help you memorize all the formulas. A lot of students falter in this because they don't understand or memorize the formulas. Do all the derivations also, okay? Just in case you tend to forget. Now, let's start working on this problem. The question is, if the screen is moved closer to the plane of slits, okay, then what happens to the fringe width? So if you talk about the screen moving closer to the fringe width, right? So to the slits, right? So we remember that the width is given by an expression which is lambda d by d. This is what we studied when we started this chapter early on, when we studied just the width of the fringes. Irrespective whether it's a dark fringe or a bright fringe, the fringe width has no change, right? It is same all throughout. So if you see, what you're doing is you are moving the screen, which is the screen where you call the viewing screen, closer to, so D is getting reduced, right? So D, capital D, the distance between screen and slits is getting reduced. Okay, so D is getting reduced, which means D, this capital D is getting reduced. And you can see this is the formula of fringe width. So fringe width is directly proportional to the distance. If the distance decreases, then the fringe width will also go down, right? So one, obviously, wherever you see will increase is wrong, right? Fringe width will not decrease, sorry, increase. So you can see, right, the fringe width will increase is wrong. Will decrease is fine, right? The fringe width will remain same. So the question talks about intensity and fringe width, right? Both are to be evaluated. One, we have decided that this is a wrong answer because it says the fringe width will remain the same. We know it will decrease, so this is wrong. So 2 and 4 are eliminated. Now the choice is between the first and third. So let's talk about first. All right, now is the tough part of this question, which is the intensity. Okay, so intensity, how does it depend on the distance? So intensity, how does it depend on the screen distance, where you have a viewing screen, right? This is very important to understand, a bit complicated, so listen to this very carefully. Now we understand that intensity resultant is given by I max, okay, multiplied by cos square into phi by 2. So phi is our phase difference, right? So the phase difference which is there between the two coherent sources is the phase difference, right? So phase difference. This is more mathematical in nature, but we have to establish some relationship between intensity and D and then decide which one is the correct. Either it is 1 or 3, because width, as far as the width goes, it does decrease. Now our dilemma is intensity. All right, so let's say you can then say that if the if the phase difference is 2 pi, okay, if the phase difference is 2 pi, the path difference is lambda. If the phase difference is 1, so this is in radians, lambda by 2 pi. And if it is phi, it is given by this much, right? So we will write this as phi, and what we get is this, right? So phi is equal to 2 pi into delta x by lambda. So I'm just looking at this part of the equation, and I have found out what is phi. So this is general expression which you must know. How do you, if you're given a path difference, how will you get the phase difference, right? So what I'm doing is I'm substituting this phi in this. So this is what I will do. So my intensity is now I max multiply by cos square and 2 pi multiply by delta x by lambda into 2. Okay, so this is it, is equal to I max cos square. So this is what you're left with, pi delta x divided by lambda. Okay, so you know what is this, is path difference actually, right? Now you still see that there is no mention of capital D as far as this particular equation goes. So let's move forward on this and say, what is delta x? Okay, if you see this figure of the Young double slit experiment, right, and you are, for example, this is your viewing screen, right? This is your viewing screen. And you're studying the fringe formation, the resultant at this point, and then of course you have this, right? This is your angle theta, which is the if the slit width is known to us, and you have to find this path difference, which is because of the only one reason, which is due to the slit, the extra distance which ray 2 has to travel. So R2 minus R1 is given by this, right? So this is your slit width, and opposite to this is your triangle we're referring to, say O A, and this is your B. So OAB, if you refer to this triangle, AB is given by D sine theta, right? The perpendicular. So D sine theta, right? So delta x actually is D sine theta. What I do is I substitute delta x as D sine theta in the expression of intensity. So my resultant intensity, right, is given by I max multiply by cos square and pi by lambda multiply by delta x is D sine theta. Okay, so D sine theta is the expression we have got so far, right? And if you see this expression, and say this is your screen distance, right? This is your screen distance, and let me draw a line here also and a line here also. See, generally this angle is also, if you remember, the angle as seen from the center of the slits. This is the center of the slit. This is the center of the slit, and I draw a line which connects these two. This angle is your theta angle, and this is the position of the. So if I have to write this, I can also write this as that tan theta is equal to y upon capital D. And if theta is very small in radians, then it can be written as theta is equal to y upon D. And similarly, if this particular expression, if theta is very small, then sine theta is also very small. So you can write this as I max cos square pi by lambda multiplied by D into theta, right? So theta is how much? We know theta. It is y divided by D, right? What I've done is I have put sine theta also equal to theta. Theta I have found from this expression as y upon d. Why I'm doing all of this? Because I want to get a d somehow and see whether it makes sense. Now, at least we have a d in the expression. But do you know that y, which is capital Y, the position can also be written as, or the nth bright fringe can be written as n lambda d by d. This is the way you can write this. So if I substitute this value, then I resultant can be written as I max into cos square pi by lambda multiply by d multiply by y I can write this as n lambda d by d divided by capital D. So capital D goes away, d also goes away, and lambda also goes away. So this is what we're left with. We're left with I max cos square into d has also got eliminated. We are left with cos square n, right? So n pi, right? This is what we're left with actually, n. So the value of resultant will be decided by the, if it's a bright fringe, then we put n. Otherwise, we could have put some other value if it had been a. So I used this expression and I converted into n lambda because I assumed this to be a bright fringe. So it's cos square n pi. If you see this expression, the capital D got eliminated, right? So if you see the resultant expression, the capital D does not exist in it's cos square n pi. This is what it is. If you go with this expression, the capital D is not dependent on the intensity is not dependent on the capital D at all. Intensity is only dependent on which order of bright fringe it is, or if I had used, for a dark fringe, the expression of n minus 1 into 1 by 2, it would have depended on that. So we have to understand that the intensity and distance, how do you establish a relationship by this whole mathematical expression and get to the answer. I hope this made sense to you. Right, so we did a lot of analysis for this question number 12A, and now we have arrived at the conclusion that the intensity will remain the same, right? So our answer number first is important. Please watch this video again for 12A, because this was a bit tough and complicated and difficult to understand. So do this with your hands also, as to how to express intensity in terms of different quantities like position of the fringe on the screen. Generally, the expressions which I have written already include that, but do the practice, because you can expect questions on this particular topic. In the entrance examination, it's one of the favorite topic to ask questions from. Thank you very much. Right, so let's move forward and attempt the part B of this question case study, right? So the question is, if you have two slits S1 and S2 are replaced by two independent but identical sources. So I hope you remember, you need absolutely identical sources, but they should be coherent. Here what they have done is they have replaced it by independent. They cannot be independent. Coherent sources which are used in YDSE are not independent. So what you will get is, you will get no pattern, because for a YDSE to happen, the mandatory condition, right, is that the single source is split into two sources, right? So everything is same about these two. So so this is the basic source, and then two slits act as two sources, but everything is identical about them. So S1, whatever is a wavefront which is entering here and here, are completely identical. You cannot have, a situation where you put this like this, right? So you have this two slits, you put a separate source here, a separate source, and a separate source. You cannot do this. This is not permissible, right? So you will not get any pattern on the screen. What you will get is just an intensity which is equal to the sum of the two intensities everywhere. Whereas, in the case of the young double-slit experiment, you get dark and bright fringes. You will not get. So the answer to this question is, no pattern will be observed on the screen, because now the sources are not coherent. The sources are what is known as incoherent. Okay. The independent sources are called as incoherent sources. They cannot give you any pattern, which is the bright and the dark fringe pattern. Let's talk about the C part. Two sources of light are said to be coherent when both emit light waves of, now very important, okay? Now what happens, what is the meaning of the word coherence? This is very important. You can see first video which I released on YDSE talks about what is the meaning of the word coherence. Very important. Let's talk about this. So different wavelength, not possible. They must have same wavelengths for them to be able to show you an experiment. So this is also not allowed. And let's look at this. So same wavelength means same frequency and constant phase difference. And this is what is the correct answer. The amplitude does not matter. The amplitude of the wave does not matter. And so one is, the amplitude is meaningless. The basic definition of coherent sources is that the coherent sources are coherent only when they have same frequency and the phase difference between them is constant. If you look into the problem number B, the independent sources do not have constant phase difference. This is one. And there is a good possibility that, okay, so they have put identical. So maybe the wavelengths are same, but they will not be able to maintain constant phase difference. And therefore, I selected this. But in this case, part C, I'm just using it to explain the part B. Remember, there are two conditions for a source to be declared coherent. The frequency also needs to be the same. So, and the phase difference also needs to be the same. If you just keep frequency of this and this to be same and these are independent, the phase difference between these two will vary. they will not be able to produce any pattern. You can only produce a pattern with coherent, for which you need a constant phase difference as well as the same wavelength. So answer number 2 is the correct answer. Now let's talk about part number D, the fringe width, right? So we've been talking about fringe width to be lambda d by small d, right? Now the fringe width is so and so. If the whole experiment, so they've used beta, which is very popular. If the whole experiment is immersed in a liquid of refractive index mu, then the new fringe width will be what? So let's talk about D, right? So capital D will not change because of immersion in a liquid. It will remain the same. Small d will not change the distance between the two slits. What will change is the wavelength. The wavelength. So if you say the velocity of light, refractive in terms of refractive index is given by the velocity of light in vacuum, right, divided by the velocity of light in the medium, right? This is the refractive index of medium with respect to vacuum. So if I convert this, refractive index of the medium can be written as lambda multiplied by the frequency, right? Lambda multiplied by frequency and lambda multiplied by frequency. So this is the medium's frequency, right? And this is the this is not the frequency, wavelength, and this is a wavelength in vacuum, air, right? Remember, when the medium changes, the frequency does not change. The frequency does not change. What changes is only the wavelength. So the lambda medium will become lambda vacuum divided by the refractive index, which means this particular quantity, which is the quantity, the lambda, which is in the vacuum, now will become this particular, it will get divided by mu. So I will find the fringe width in the medium to be lambda divided by refractive index multiplied by d upon d, right? So this is the way you need to write, and you can see clearly that the fringe width has gone down by a value of mu. So your fringe width in the medium is coming out to be the fringe width in the vacuum divided by mu. So your answer number 3 is the correct answer. The fringe width will go down. Generally, refractive index is always greater than 1 for any medium, right? Air and vacuum is supposed to be 1 or 1.001, very little. And so I hope this is also clear to you. This is more mathematical. Some minor variations have been brought in the questions by doing this little changes that do the experiment in another liquid and stuff like that. So I hope this is clear. Let's move forward to the next part of the question. Okay, let's see what it says. Okay, so let's do the next one. The total path difference between the two waves meeting at point are 3 by 2 lambda and 2 lambda. Okay, then the bright fringes. So what they're doing is they're looking at two different points on the screen. Let me just draw the diagram, and then let's establish what will happen there. So this is the experiment which is happening. There is a viewing screen, and the viewing screen is creating, so one is this point, maybe they're studying this point, and this point is P1. Okay, and at P1 the path difference is 3 lambda by 2. So the path difference that has got created here is 3 lambda by 2. 3 lambda by 2. We have to decide based on the path difference what exactly is the nature of fringe which gets created. Do we get a dark fringe or a bright fringe, right? So if you just by looking at the odd multiple of the lambda by 2, so if you see any expression where they use 2n, sometimes they use 2n minus 1 like this. If you put 2n is equal to 2 here, right? So let's say you're trying to find a dark. So this expression is for a dark fringe. I will just substitute lambda by 2. 2 into 2 minus 1 is equal to lambda by 2 into 3, right? So this is a second order dark fringe. So at point P1 where the path difference is 3 by lambda 2, the expression of dark fringe, right, has fit in very nicely. So this path difference expression, fits in very nicely. This path difference is for a dark fringe. This is for a dark fringe. So this was so the answer to P1 is a dark fringe. So I know this. So P1 is cannot be bright. So automatically second may be right, but let's check for the 2 lambda also. So let's say 2 lambda, this is point P1, and then let's say you study another point, which is this point, right? So you're studying the interference pattern is happening here. Another interference pattern of some fringes happened here also. This is P2, but the path difference here is 2 lambda. So if you look into the path difference which is required for a bright fringe, it is generally given by n lambda, right? Plus minus is also used. And if I put n is equal to 2, I will get delta x is equal to 2 lambda. It fits in, right, with 2 lambda. So even at P2, you will get an interference pattern which is of a bright fringe. So the answer number second is the correct answer. So through this numerical, I hope you had a good revision of the whole young double slit experiment. I will bring out more case studies. You can see that this is the only channel in the country which is providing explanation. No application, no classroom training, no web portal, nothing will provide you this level of detail which I am providing. Do not forget to subscribe to this channel because I'm going to bring up some very important questions. I already have around 2000 questions on my YouTube channel. Please help me spread this across the country so that I can impact 1 million students. Already this particular channel is being watched in Philippines. It is being watched in America. It is being watched in other neighboring countries and some Latin American countries. So I want to go and help a lot of students who are weak in physics or want to improve on physics or want to learn physics at the comfort of the home without paying a lot of money. So you have a free facility available. Please spread this channel within your family. A lot of students can benefit who are in class 11th, 12th, preparing for physics, entrance examination, board examination. And I will bring out more case studies as per your recommendations. So wait for my next case study, which is very important. It can fetch you 5 marks. And thank you very much for your time today.